Imagine you have all these microservices which depend on each other. A depends on B, B depends on C, C depends on D, and B might be interacting with services E and F. Now, if any of the upstream service fails, it may actually impact all the downstream services as well, resulting in cascading failure. To prevent this from happening, we can use circuit breaker mechanism. It kind of works like an electrical circuit, which stops the flow of electricity whenever there is a problem in the circuit. In this case, let us assume that service D is very unreliable, meaning that it is very prone to downtime. So we will have to implement circuit breaker mechanism in service C, which is sending request to service D. The circuit breaker monitors the success or failure of each request. Initially it would be in closed state, meaning that everything is functioning as expected and none of the components are showing any signs of errors. This is somewhat similar to a real electrical circuit where electricity flows when there is no problem in the circuit. However, if service D goes down for whatever reason, and if the failure rate exceeds a certain threshold, it transitions to an open state and it will stop all requests to the failing service. During this time, any new requests are automatically rejected with an error message or some sort of fallback mechanism. So instead of allowing the request to wait or retry endlessly, the circuit breaker fails fast, returning an error to the calling service, and the calling service might handle the error gracefully. Or we might have some sort of fallback mechanism to provide default behavior in case of failures, improving the user experience even in adverse situations. For example, if product recommendation service fails, instead of sending an error message, we might want to show some generic recommendations. Or if it is a payment gateway that fails, we might offer try again option or might show alternative mode of payment to the user. The fallback mechanism consumes far less resources than allowing requests to pile up. So this way we'll be able to avoid resource overload and gives dependent services time to recover. This also prevents additional strain on the failing service and allows it some time to recover as well. After a certain time, the circuit breaker moves to half open state, where it allows a limited number of test requests to pass through. If these requests are successful, the circuit breaker transitions back to closed state, and the system will resume to normal operations gradually. If it still fails, then it will move back to open state and will not allow any requests. In our previous example, since the payment gateway service is not so reliable, we might want to introduce circuit breaker mechanism in the payment service. So that payment service may actually return an error instead of piling up all the requests. An order service might handle it gracefully. Maybe it will reset the inventory, for instance. And the user might be seeing an error message or might be shown with an alternative mode of payment option. We don't have to implement circuit breaker mechanism in every service. It can be implemented in scenarios where service relies heavily on critical upstream dependencies, such as another service or database which is prone to latency or downtime. For instance, consider a payment service that depends on an external API for processing transactions. It's also essential in high traffic or high load environments to prevent cascading failures during peak times. Additionally, circuit breakers are crucial for non-idempotent operations, like money transfers where repeating the same operation could cause issues. Lastly, circuit breaker is also important in systems with chain dependencies where failure in one service can ripple across multiple downstream services, potentially disrupting the entire workflow. You can skip or defer implementing a circuit breaker in scenarios where the service is simple or operates in isolation without dependencies such as a local logging or metric collector. It's also unnecessary for services that are rarely invoked and where the impact of the failure is minimal. Similarly, circuit breaker may not be needed for non-critical services with low business impact, where failure don't significantly impact the user experience. Once after we take a look at an example of circuit breaker, you'll have a better picture. So this is how we can introduce circuit breaker mechanism. Initially, we have to add the dependency. Obviously, it's best to use Spring Boot because it offers auto configuration, which will save us from having to configure everything manually. Once you include the dependency, we have to add the necessary configurations in the YAML file or in the properties file. The sliding window size specifies the number of calls to monitor, while the failure rate threshold defines the failure percentage at which the circuit breaker will trigger. The wait duration in open state determines how long the circuit remains open before transitioning to half open state, and permitted number of calls in half open state, as the name indicates, it sets the number of test calls allowed during the half open state. Once we have these configurations in place, we can start using circuit breaker mechanism, and here is the sample code for the same. In this MyController class, the API endpoint is protected by a circuit breaker with the name myService. It's the exact name which we have used in the configuration file as well. The circuit breaker annotation specifies a fallback name called fallback in this case, which is invoked if the service fails or the circuit is open. The call service method makes call to the external API or to another service which we assume is unreliable, and if the service fails, the fallback method returns a response indicating that the service is temporarily unavailable. If it is success though, we're going to return the success message. Initially the circuit would be in closed state, the service is called normally, and failures are tracked. When the failure threshold is reached, the circuit breaker moves to open state, blocking further calls. After the configured duration, the circuit transitions to half open state, allowing limited test calls to check if the service has recovered. If the circuit remains open or a failure occurs, the fallback method is then called.